Alright, so we're going to solve systems by elimination. Alright, first step that we always want to make sure is that both equations look like that. You have an x, then a y, and then a number. Okay? Alright, so we're probably going to have to multiply one equation, or possibly both, so that when we add the two equations together, right, variables are going to cancel. After that happens, when variables cancel, we get pretty happy because then we only have one variable, and in a math problem, having one variable is really cool. Yeah, sorry. No, really it is though. Because then you can solve it. You know, you have two variables, you're kind of stuck with this x and this y, right? So when you have one variable, life is good, and you can get an answer and move on to the next question. So once we get one variable, then we solve for it, and then we plug back in to find the other one, which is a step that everybody wants to forget because who would want to remember that, right? All right, so let's move on to actually solving the questions. First problem. It looks like I have a 3y and a 3y. Okay, so the easy way of solving this problem would be to multiply by -1. So we're going to multiply this first equation by -1. And that's going to give us -2x minus 3y equals -2. The bottom equation is still positive 5x plus 3y equals 14. But notice what happens when I put that plus sign there and I start thinking about adding. Okay, when I go to add them, works out pretty well. I end up getting 3x with the x's, because -2 and 5 makes 3x. The -3y and the positive 3y cancel. Hey, look at that. I now only have one variable. That's the goal here. -2 plus 14 on a good day makes 12. So when 3x equals 12, we can divide by 3. All right. I typically don't write that, but I have the room. So we get x equals 4. And there we have it. Now, we've got to be careful because this is a system. Okay, and a system has an x and a y, and right now we only have the x. So taking one of your original equations, you take that x equals 4, and you plug it in. Now I'm going to choose this top one here because, well, 2 times 4 is much easier than multiplying 5 times 4. So 2 times 4, although not really a whole lot, but whatever. I always choose the easier of the two. Okay, so 2 times 4 plus 3 times y equals 2. That would be 8 plus 3y equals 2. I'm going to have to subtract the 8 over. I don't have the room, and to be quite honest, you're at the stage where I think you can do 2 minus 8. If you can't do 2 minus 8 in your head, use the calculator. You still don't need to show the work as far as I'm concerned. So 2 minus 8 is -6. And then we divide by 3, and again, I don't have the room, so I'm just going to write y equals what -6 divided by 3 is -2. So I have my answers, 4 and -2. Okay, and there we have it. All right, the second example 1, because having 2 example 1s is awesome. Whoops. All right, so that's supposed to be example 2, and whatever. So we want to make it so that the x's and the y's cancel somehow. Now in the first question that we did, it worked out really nice because there was a 3y and a 3y, and that was nice. Life was good there. In this question, it's not so nice. So we want to get rid of something. All right, well, multiplying by -1 just isn't going to cut it, so I could multiply by 7 up here and make this 28, and by 4 right here and make this 28, but that's larger numbers than multiplying by 2, or by 3 and by 5. So I'm going to choose the smaller of the pair of numbers just to make life a little bit easier. That's typically what we do. It makes the problem deal with a little bit smaller numbers, and when we get into the 3 by 3 systems that have x, y's, and z's, it's going to be very important that you choose the easiest method possible. That way you don't make simple mistakes, which is inevitable anyways. But all right, so we're going to multiply to get rid of the x's. So I'm going to multiply by, oh, I guess 5. And I'm going to multiply this guy right here by -3. When I do that, I'm going to get a 15x that's positive on one and a 15x that's negative on the other, and that is the goal, so that they will cancel out. So 15x plus, that's supposed to be a plus, 20y equaling 45. And then the next one, when I multiply the -3 in, I'm going to get -15x. I'm going to have a positive, that's pretty close, 21y, and it's going to equal 3 times negative 26 would be 75, 3 more, so negative 78. Positive. Sorry, positive. They're both positive. They're both negative, so that becomes a positive 78. Anyways, let's add them up, and life should be good. So 15x and a negative 15x makes 0, and then our 21 and our 20y will make a really large number, 41y. Interesting. And then we have 45 and 78, which is going to be 123. And hopefully when we divide this it works out. If not, that means that we made a mistake, and that happens, and we just go back through and double check. So 123 though divided by 41 works out to be 3. Again, don't be that person that gets a partial credit on this question by stopping here. You get 1 out of the 2 points. You need to plug back in. So choose the easier equation. It looks like the top equation to me is the easier one because it doesn't have 7 times something and a 26 in it. So I'm going to choose the very top equation to plug in y equals 3. So it's 3x, come on, plus 4 times the y, which we're going to plug in 3, equals 9. Again, we're using our original equation. We're not using one of these modified ones over here. All right, so 3 times x, here we go, plus 12 equals 9. Subtract the 12 over. Again, you can use your calculator or your brain. That works too. 9 minus 12 is negative 3. We divide and get negative 1. So I have negative 1, 3. Oop, that shouldn't be that. Negative 1, 3 is my ordered pair for this system. We're done.